So this time we're going to take our knowledge. Of solving a system of equations and apply it to some type of a verbal scenario where we create and solve a system of equations from a context, from a story, if you will. So first of all, let's talk about how we're going to create equations like that. So we have a school's marching band. They want to raise $1,000 to buy uniforms. They're going to have a car wash, $5 for a small vehicle, and $8 for a large vehicle, like a van or an RV. So let's talk about how we can maybe define some variables and then write an equation for that. So because there's so many different ways to earn a $1,000 profit, what we're going to say is that if we start with the large vehicles, and what we'll say is that X is going to represent the number of large vehicles washed, then it would make sense that if we multiplied $8 per vehicle times X, we would get the expression 8X. And likewise, if we let Y represent the number of small vehicles washed, then each small vehicle will be charging $5. So if we multiply them together, 5Y represents the profit from washing those small vehicles. So then the total profit, the expression 8X plus 5Y, this expression here represents the total profit from washing large and small vehicles. Now to take that expression and make an equation out of it is what we did below. That this equation, 8X plus 5Y equals 1,000, shows washing large and small vehicles and earning a $1,000 profit. So that's the idea about how we create these equations. So let's take a look at another context and we'll create equations and we'll solve them. So why don't you pause the video here for a minute and see if you can define variables and then write a system of equations. Okay, let's give it a shot. Alrighty, so as I read through this, the Montagues and the Capulets go to play together. Montagues buy 2 adult tickets. So I'm looking for like prices of adult tickets and things like that. So what if I say that variable A is the cost of an adult ticket? And we'll let C represent the cost of a child ticket. So now it says the Montagues brought 2 adult tickets and 3 children tickets. So what if we think about something such as 2 adult tickets plus 3 children tickets? And that's going to cost them a total of $16. And likewise, then it says the Capulets purchased 3 adult tickets and 2 children's tickets, and they spend $19. So did you get those 2 equations? Oh, I hope that you did. I'm just going to create a little bit of room real quick because I'm going to do something to them. You know what to do from here. So let's see. Did you maybe multiply the top equation by -2 and the bottom equation by 3? That's a good strategy to do. When I do that, I'm going to get -4a and a -6c equals -32. And I'm going to get a 9a plus 6c equals 57. Great, it's just what I wanted to have happen. My variables in the middle, the c variables cancel out. -4 plus 9 is 5a. 57 subtract 32, or -32 plus 57, is going to equal 25. If I divide both sides by 5, a is equal to 5. Let's use that to figure out the cost now. I go back to one of my equations. So maybe 2 times 5 plus 3c is equal to 16. I'm solving for c now. 2 times 5 is 10. Subtract 10 from both sides. 3c is equal to 6. So the cost of a child ticket is 2. So now it says, so solve it and state the cost of one of each. So let's state what they are. Adult tickets, they're $5. Child tickets, they're $2. So notice that I wrote the equations, I solved the equations, and then I stated what my answer was. Great, let's try one more. One number is 4 less than twice another number, and the sum of the numbers is 32. So let's say maybe that we define our variables as x is one number and y is maybe the other number. So let's see if we can come up with the equation for the first sentence. One number is 4 less than twice another number. Translating that into some algebra, maybe we'll say things like, there's a number that's equal to, let's see, 4 less than means I got to do this, because it's 4 less than something. It's 4 less than twice the other number. So there's my first equation. Can you write one for the second equation? Sum of the numbers is 32. So I'm going to add those two numbers together, and I'm going to get 32. Great. So what method do you think is best to solve this? Hopefully you picked substitution. It doesn't really matter which one you choose, but this one screams, solve me by substitution. Okay, we'll satisfy that demand. So I know that y is equal to 2x minus 4. So I'm going to take 2x minus 4, and I'm going to replace it with y. And that's going to give me the equation x plus not y, but 2x minus 4 equals 32. So can you solve that equation to find the two numbers? Let's see. X plus 2x is 3x. I'll add 4. So 3x is equal to 36, and x is equal to 12. Now I know that the two numbers have to add to 32, so then the y value is going to be 32 minus 12, which is going to be 20. Or you know what would have probably been better if I plugged it into one of the equations, because I want to be consistent. So we learned that we like to plug it into maybe the top one. So y equals 2 times 12 minus 4, and that's going to give me my y equals 20. So determine the two numbers. We did that. We'll say that x equals 12. We'll say that y equals 20. So hopefully translating from a verbal system to an algebraic set of equations is something that you can do, because once you do that, oh man, we just solved.